This meeting is being recorded.
In this next video from chapter 15 on chemical equilibrium, we are given this equation here in our worksheet, and it relates Kp, the equilibrium expression, constant Kp, to Kc. And we should note that since pressure is proportional to concentration for gases in a closed system, these equilibrium constants can be related using this equation here. So this is a good equation to note when you're taking your exam, that the change in moles here, this delta N, that's given, or can be found rather, from the chemical equation. So we have a chemical equation right here, and we're going to just subtract the moles of reactant from the moles of product. So that's where we get that delta N, or change in the number of moles of gas. And Kc or Kp could be given. You can solve for the other variable. As long as you have temperature given as well. And then the gas constant is just that, our gas constant of 0.08206. So we can plug in these values into this equation. And in this case, we're asked to solve for Kp. So let's take a look here. We're going to solve for Kp. We're going to rewrite this equation here, Kc times RT to the delta N, to the change in number of moles. So it's important to note that when you're solving this, you follow order of operations, and you'll do your exponent, right? So parentheses first, rather. So what's in the parentheses, we multiply these, then we raise to our exponent. If you recall, parentheses, exponents, then multiplication, division, addition, subtraction. So we'll do multiplication later on. So step one, let's plug in these values and then follow the order of operations here to get our right value. So here's my Kc at 1,000 Kelvin. So that's going to be 0.0821, we can shorten it to, times my temperature, 1,000 Kelvin here, raised to my change in moles. So we can do a side calculation here. The delta N will be specifically 2 plus 1, so 3 for products, minus 2 moles from reactants. So 3 minus 2 gives me a 1. So whether I forgot that delta N or not, we're just plugging in a 1 here, so it will not affect our calculation since it's raised to the first power. So let's do now the what's inside the parentheses here. So we'll multiply that first, raise it to the first power, and then when we multiply by Kc here, we should get a value around 0.335. That looks good because the only value that we were given also had 3 significant figures. So again, this would be our Kp that we solved for. These constants are unitless, so this is our final answer down below.